3. Given the roots of two binary trees P and Q, write a function to check if they're the same or not. Two binary trees are considered the same if they are structured identically and the nodes have the same value. So these two tree reads are the same exact ones. The left child node matches with the right child node, and also so does the parent nodes. And this one isn't the same because this one is the root node, and the left child node is 2, and this one's the root node, and the right child node is 2. So they don't match. The 2 here is the right child, and the 2 here is the left child. And this one also same concept as this. Yeah, but it has the 2 mixed up. The left child here is 2. The left child here is 1. Right child here 1. Right child 2 here 2. So we get false. So how will we do this? Well, we're going to this is an easy one that we can easily solve with a recursive method. Recursively solve this by calling on the function. Let's make the cases, the conditions on how we're going to save these. So so let's start with if there's nothing in it. What if there's nothing in it? If P is none or Q is none. So sorry, and Q is none and none. So if both of these nodes are none, the roots are none, then we get a true statement. Also, let's make another one. So if either one of them is none and the other one is true, so if P is none or Q is none, or the P value is not equal to the Q value, or the P dot value is not equals to the Q dot value. Return false. This one should return to I return true. If both P and Q are none, K, K us true. Two truths here. If either if either P or Q is none, if one if Q or P is none, and all the values don't match. So that's what this is. So now let's make our return statement, since we need a boolean sign, and let's make a recursive self that, since we're inside, so since this is a method, we start with a self that it's same. Let's call on the method 3 P dot, let's start with the left values, left Q dot left and self that is same 3 p dot right p dot right. This will be oops, two p's kills 2 p's. Okay, so our time complexity will be O of n since each node will be visited once. Space complexity is OH being the size, the height of the tree. And let's see if we have everything that we're supposed to. Oops, this is not needed. Let's run it and see if it works. Yes, and it's been able to pass cases. This is an easy one. Learning how to use binary trees, and we solved it recursively. And that's it for this one. Wait, let's submit it to make sure that it passes all cases. Yes, and it's been able to pass all cases.